Hi, this is Professor Fernandez. This is the first video in Lesson 5. We'll be talking here about evaluating two-sided limits using these three graphs. And this example that we'll be doing comes from Calculus Simplified. Okay, so let's look at the example. This is example 5 in chapter 2. It says, referring to the figure, and I've just copied it 3 times here, evaluate the following limits if possible. Okay, so that's a tip-off that some of these limits may not exist, and we'll talk about why in a second. So because these are two-sided limits, right? Let's take a look here, and I'll tell you in a minute how I can tell they're two-sided limits. Let me remind you of the criteria for a two-sided limit to exist. So we'll put it down here. So it's a three-part check for two-sided limits to exist, right? So the first part is that the left-hand limit and the second part, the right-hand limit, these must exist. Okay, in other words, must equal some number. And then the third part is that both numbers must be the same. What I mean by that is maybe the left-hand limit exists and it equals 7. Maybe the right-hand limit exists, it equals 13. So you've satisfied the first two of these criteria, but you have not satisfied the third because 7 and 13 are not the same number. So that's what I mean here by the third one must equal, both numbers must be the same. Great, so then let me scroll up to the first example. Okay, how do I know this is a two-sided limit? Well, I'm looking here, right? It says x approaches -1. There is not a superscript here. There is not a -1 from the right or a -1 from the left. Those would be one-sided limits. So that's how I know, and then zooming out here, that all of these, looking here, and then also looking here, are questions about two-sided limits. Okay, great. So now that I know it's a question about two-sided limits, and I have my criteria for a two-sided limit to exist, we're going to go ahead and evaluate that for each of these three examples. To do that, I'm going to use the ribbon method that I've been using in previous videos, and also remind you while I'm doing that if you need a refresher on using the ribbon method to evaluate one-sided limits, or just how to evaluate one-sided limits, the videos 4.1 and 4.2 in this series do that. So check those out. Okay, great. So how do I do this? Well, I'm going to go to -1 on the x-axis. There it is down there. And then I'm going to draw a ribbon around x equals -1. The point of drawing this ribbon is to remind you that the limits only care about the function's y values trend as we are close to the x equals c point, in this case, -1. So the ribbon is in fact meant to have you think about, well, it doesn't really matter what's going on over here for the purposes of the limit, or what's going on over here, right? The only thing that matters really is in a neighborhood, in a very close proximity to x equals -1. All right, with all that being said, so how do we actually figure out this limit? Well, first criterion down here, we want to look at what happens as I approach from the left. Okay, so if I approach from the left and I'm marching along the function, it looks like my y values tend to y equals 2. So I'm going to say here as x approaches -1 from the left, the y values tend to 2. Okay, so now I'll go down to the second criterion here. What if I approach from the right? Let's try that. So if I'm approaching from the right, what are my y values tending to? You can see that I'm getting closer to y equals -1. So as x approaches -1 from the right, the y values approach -1. Okay, and then what about the last criterion? Question, are both of these numbers the same, right? Both of the numbers that we have obtained. And the answer is no. Let me use a different color that looks like all the x's I've been using. The answer is no. 2 and -1 are not the same. So I conclude that not all of the criteria are satisfied for the limit to exist. Therefore, this limit does not exist. Does not exist. Okay, so I have shown you how to do this with a very detailed check of the three criteria for the limit to exist. Let me just now go back and erase all this and make it a bit simpler and show you the visual way that you could figure this out. You would do much the same thing we just did. You would say, hey, it's a two-sided limit. X is approaching -1. Let me draw my ribbon. And then now you look at the trend in the y values, right? If I look from the left-hand side, the y values are trending that way. If I look from the right-hand side, the y values are trending this way, right? These are opposite directions. So the left-hand limit and the right-hand limit are not converging, if you will, not trending to the same y value, and specifically a y value that exists, right, a number. So that's another visual explanation for why, in this case, the limit does not exist. All right, so let's slide over and apply some of that to speed up the calculation of this limit. So we're looking here at x equals 1. So I'm going to find 1 on the number line, and then draw a ribbon here, and then do the same analysis. Okay. So as I approach from the left here, it looks like, oops, that's still on marker form. As I approach from the left, it looks like the y values are getting closer to y equals 1. Great. As I approach from the right, it looks like the y values are also getting closer to y equals 1. And 1 is a number, so my conclusion is that all three criteria for my limit to exist are satisfied, and the answer is 1. And again, you can see that from the graph, right? As you approach from the right, you're tending toward y equals 1. As you approach from the left, you're tending toward y equals 1. Same number, so limit exists. Last example here. So here we are approaching 3. So I'm going to find 3 on my number line. There we go. And then I'm going to draw my ribbon around 3. There's the ribbon. And then same pair of questions, right? So what happens if I approach as I approach from the left? Looks like the y values are tending to y equals 1. And then as I approach from the right, it looks like the y values are tending also to y equals 1. And then 1 equals 1, right? They're the same, left and right limits are the same. So I conclude that this limit is also 1. Okay, you might worry here, wait a second, what about this? You know, the y value at 3 is 2. Why isn't the answer here 2, right? And the answer is because we're calculating a limit, right? The question does not ask for f of 3. F of 3 means what is the y value at x equals 3? And that really is 2. So that answer is 2. But here we're asking for as x approaches 3, but never arrives at 3. What do the y values of f of x tend to, right? And the answer is 1. And we got that by exactly this type of ribbon analysis. All right, so I'll zoom out here to just recap really quickly. You'll see that one of these limits did not exist, again, because there was a different trend in the y values as we approached from each side. The other two limits did exist because the y values converged, if you will. They approached the same y value. It did not matter whether the actual y value at the point was the same that the function was tending to, right? It was here, it was not here. So don't worry about that, because again, we're calculating limits. Okay, and then the last thing I'll mention really quickly is you'll see in the next video over here, video 2, what happens at this vertical asymptote, where the left and right y values are going to the same direction, but the direction they're going to is toward infinity, which is not a number. Okay, so we'll preview and figure out what happens in that situation in terms of limits in the next video.